A very typical kind of solubility problem. We're given the solubility product constant, and we want to know how much of the salt we can actually dissolve in water. So the first thing you want to do in problems like this is to write down the dissolution equation and then write down the KSP expression. In this case, it's the concentration of lead ions times the square of the concentration of bromide ions. Now what we don't know in this problem is those concentrations, so we're going to use a little algebra. We'll let x equal the concentration of lead 2 plus, and then if x is that concentration, and we remember that the bromide concentration is twice that, we get that from the stoichiometry of the problem right here, and then we can just rewrite the KSP expression using those variables. Now don't forget the square here. That's important. Sometimes this is a little counterintuitive. You have the 2x and you also have the square. It seems like you're sort of doubling up on things, but you're really just following the mathematics. There's twice as much bromide ion as lead ion, and the KSP expression says that that quantity has to be squared. Now we can just do a couple quick algebra steps. We'll square the 2x, so that gives us 4x squared. And I'm just going to write this out so it's all very clear here. The next step is to multiply the x by the x squared to give us 4x cubed. And then we'll divide that 4 over to the right side, or divide both sides by 4 to get 1.65 times 10 to the minus 6. And then to solve for x, we're going to remember our laws of exponents, and we're going to raise each side of the equation to the 1/3 power, and that's just taking the cube root. But it's a lot more handy in these problems to just stick with the 1/3 power. And the way you do that on the calculator is just to enter the number 1.65 times 10 to the minus 6, use the power sign, it's the caret sign on this calculator, and just raise it up to the 1/3 power, and that takes the cube root. So there's your answer. The concentration of lead ions is 0.0118. I think I had 0.012 on the calculator, but I had fewer digits on that particular calculator. So the lead concentration, the maximum lead concentration we can have in a saturated solution is 0.0118, and then the bromide concentration will just be twice that. So that's it. These problems are all a lot like this. They involve a little bit of tricky algebra setup and a couple tricky algebra steps, but not too bad.